Hello, my name is Jean-Stéphane Baudot. I am a French qualified actuary and head of the pricing and modeling team at SCOR P&C, covering both reinsurance and insurance. In reinsurance, cedants' portfolios are usually large enough to support experience-based pricing methods. Depending on the type of coverage, we model either total losses using aggregated data or individual losses using detailed data. For long-tail business, we often rely on triangulated aggregated data and apply the standard chain ladder method to estimate development patterns and ultimate losses. This approach tends to produce stable and reliable results when sufficient data is available. However, in insurance and facultative reinsurance, many of the pricing methods used in traditional reinsurance are not suitable for large corporate risk due to limited data availability. For long-tail lines, aggregated loss triangles often contain many zeros, making the chain ladder method inappropriate. In such cases, the triangle-free reserving method developed by Pietro Parodi can be highly valuable for pricing. Actuarial research has already shown that this method can be more accurate and predictive than the standard chain ladder approach. For this reason, I have proposed to Pietro to sponsor a thesis to continue his research on triangle-free reserving. This thesis will be funded by the SCOR Foundation and jointly supervised by Pietro acting as the technical advisor and Denis Pomeray, professor and researcher at the Institute of Mathematics of Marseille, serving as an academic supervisor.
Hello, my name is Pietro Parodi. I am a UK qualified actuary and I lead the Quantitative Methods and Tools team, which is part of SCOR P&C operations. I specialize in the methodological aspects of non-life insurance pricing and reserving. Around 13 years ago, I developed a methodology for reserving that, instead of relying on aggregated loss data structured into triangles to project losses for each year, utilizes the most granular level of available information. This methodology was then presented at a conference, received the Brian Hay Prize in 2013, and was later published in the British Actuarial Journal. While I developed this methodology independently, the idea of granular reserving had been around since the 90s, although this had mostly remained in academic circles. And I believe that my paper represented the first attempt to show a full-scale, real-world implementation. More in detail, the idea was the following. Traditional reserving methods are what they are because when they were developed, computing power was limited, and therefore it was important to be able to aggregate information in a way that was easier to implement. Reserving methods would probably be very different if we had had computers at the time. Using more granular information in reserving is important. An analogy I'm fond of using is that of image compression. If I take a picture of this nice place in Devon with my phone at high resolution, or what used to be high resolution 13 years ago, and I reduce it to the size of a logo, let's say 16 kilobytes, I can still figure out that it's a picture of a harbor, and I can see that there are cars, boats, houses, possibly a castle. But I'm losing many of the details that I can discern in the high-resolution version. For example, that one of the houses is actually a hotel, and zooming in a bit, that the hotel is the Royal Castle Hotel in Dartmouth. By compressing the image, I have experienced some serious information loss. The traditional reserving approach suffers from similar problems. You may have, say, 5,000 claims over 10 years. Here we have an extract of an example, and this contains plenty of detailed information. However, the standard approach is to compress all this information into a triangle, a half matrix, that will have 55 points, one for each combination of accident year, the year when the claim happened, and development year, the number of years elapsed between occurrence and reporting. But can you really trust the results after all the information loss? And this is not the only problem with the traditional approach. Another problem is that projecting the reserves typically involves actuarial judgment, which often translates into tweaking development factors with no immediate interpretation in terms of a loss production process. Finally, there is a disconnect with pricing. Reserving measures the risk retrospectively, while pricing measures it prospectively. However, the risk is fundamentally the same, but in pricing it is measured at a more granular level. The idea was then to develop a frequency-severity approach based on the collective risk model, in analogy with what we do in pricing. This produced a practical solution that we've been regularly using, for example, in claim count projection in pricing. However, many questions remain unresolved, of both a theoretical and a practical nature. This project is aimed at advancing on these questions. More in detail, what I personally expect from this project is threefold. First, I expect that we'll be able to gain an understanding of the relationship of triangle-free reserving with the other granular reserving methods developed in academia. Second, I expect that using independent loss generation processes, we can prove under reasonably weak assumptions that triangle-based methods do not produce the true reserving distribution, even asymptotically, and that triangle-free reserving with minimal or no human interaction outperforms systematically triangle-based methods across the board, but especially when data is scarce. And third, I expect that we will be able to delve deeper into the theoretical aspects of the methodology, addressing, among other things, the dependencies among the various variables and the role of external factors.
Hello, my name is Denis Pommeret. I have been a professor of statistics at Marseille University since 2006. I launched an actuarial program and built partnerships, notably with ISFA, which is the Institute of Financial Science in Insurance at Lyon, where I was associated from 2019 to 2022. I am also an actuary and the holder of the Action Share of Excellence, which focuses on risk modeling and the evolution of policyholder behavior. I know SCOR beyond its reputation. First, several SCOR managers teach in her master program. I am familiar with the work of Pietro Parodi, which is both timely and highly valuable. Funding from the SCOR Foundation will enable us to continue Pietro's work and to advance other recent approaches, including triangle-free methods and micro-level reserving. Together with my colleague Xavier Milot, who is Associate Professor at Aix-Marseille University, French Qualified Actuary, and, among other distinctions, a SCOR Prize laureate, and our PhD student Matthias Wegbenu, who was major of his Data Science Master Program, we look forward to collaborating on this exciting project. We anticipate 3 years of rich collaboration between London, Paris and Marseille, and certainly beyond within the actuarial community.